262,144. Yep, you heard that right. That is the absolutely massive maximum token context window of Alibaba's new Qwen 3.6 models. Look, we are dealing with serious scale today. We're talking about a context window capable of holding entire codebases or, whole novels in memory at once. And get this, it can even be extended to a staggering 1 million tokens via Yarn. But here's the ultimate challenge for us developers, researchers, and everyday hobbyists. How do you actually run a beast like this locally, right? Like, how do you harness that immense power right on your own machine and completely dodge those insanely high recurring cloud API fees?
Well, let's dive right into it. Welcome to this explainer, where we're going to do a deep dive tech keynote on exactly how to run Qwen 3.6 locally using the brand new Unsloth Studio. We're going to unlock state-of-the-art performance right on your desktop. It's going to be awesome.
So here's our roadmap for today. First, we'll meet Qwen 3.6 and Unsloth. Then we'll cover hardware and memory requirements. After that, the MTP speed breakthrough, followed by mastering hybrid thinking modes, and finally, setup and real-world performance. Let's get into it.
All right, Section 1. Meet Qwen 3.6 and Unsloth.
So, Qwen 3.6 comes primarily in two seriously powerful flavors for local deployment. You've got the 27 billion parameter model and the 35B A3B model. These are multimodal, hybrid thinking models, and they natively support an astonishing 201 languages. But most importantly for us developers, they absolutely excel in three core areas: agentic coding, complex vision processing, and advanced chat tasks. Plus, they even feature built-in developer role support for tools like Codex and OpenCode.
Now, to run these, we're using Unsloth Studio. You can basically think of this as your new command center. It's a brand new open-source web UI specifically designed for running, downloading, and even training local AI models. And it doesn't matter if you're on macOS, Windows, or Linux. It offers self-healing tool calling, web search, and automatic inference parameter tuning, all backed by blazing fast CPU and GPU inference via llama.cpp. Because honestly, despite the name, there is absolutely nothing slow about Unsloth.
Moving on to Section 2, Hardware and Memory Requirements.
Okay, so when we're mapping out hardware requirements, we're really looking at total memory. And by that, I mean your system RAM plus your VRAM. If you want to run the 27B model using highly efficient 4-bit quantization, you only need 18 gigabytes of total memory. Not bad, right? Step up to the 35B A3B model at 4-bit, and you're looking at 23 gigs. Now, for the purists wanting to run the massive unquantized BF16 versions, you're going to need between 55 and 70 gigabytes. The key takeaway here? You just need to make sure your total available memory exceeds these file sizes for the absolute best performance. Otherwise, you're going to fall back to slower SSD offloading, and nobody wants that. Wait, I need to jump in here with a super important warning straight from the Unsloth docs for my NVIDIA users. Right now, whatever you do, do not use CUDA 13.2. Seriously, if you do, you run a very high risk of the model outputting absolute gibberish. NVIDIA is actively working on a fix as we speak, but for now, just stay far away from version 13.2 so your generations actually make sense.
All right, Section 3, the MTP speed breakthrough. So this new multi-token prediction, or MTP, literally changes the game for local inference. In standard generation, a language model acts sequentially. It predicts just one single token at a time. It's a huge bottleneck. But with MTP speculative decoding, a smaller draft model predicts several future tokens all at once. Then the main heavy model verifies those drafted tokens in parallel. It's incredible. It drastically reduces the number of forward passes you need to make.
And the result of all that parallel verification magic? A massive 1.4x to 2.2x speedup in generation times. And honestly, the absolute best part of this engineering feat is that this speedup comes with literally zero change in accuracy. You're getting the exact same high-quality outputs, just up to twice as fast. To put that in perspective, the 27B model with MTP now runs at a blistering 160 tokens per second on an RTX 6000 GPU. It's wild.
Now, if you're the type to set this up manually in your terminal, the optimal baseline setting you want to use is spec draft-n max 2. The Unsloth team actually found that if you push past 2 draft tokens, the acceptance rate just drops off a cliff from about 83% down to 50%, making it way less beneficial. Just keep in mind, MTP does require about 1 extra gigabyte of VRAM headroom, but trust me, the speed trade-off is absolutely worth it.
Section 4. Mastering hybrid thinking nodes. Because Qwen 3.6 is a true hybrid reasoning model, tuning its parameters is a lot like playing a game of chess. Thinking mode is essentially your grandmaster, meticulously planning 5 moves ahead. To control that grandmaster for general tasks, you're going to want a higher temperature of 1.0 and a presence penalty of 1.5. But if you're doing precise coding tasks like web development, you've got to rein it in. Drop that temperature down to 0.6 and the presence penalty to 0.0. Unsloth also brings in this really cool new preserve thinking feature. It actually leaves the model's invisible thinking trace from previous turns right in the context window. Sure, it eats up a few more tokens, but it significantly boosts accuracy in those long, complex back and forths.
Now, if we contrast that with non-thinking, or instruct mode, which is honestly more like speed chess, relying on rapid, trained instinct, the parameters shift completely. For general, quick tasks, you'll want to drop the temperature to 0.7 and the top_p to 0.8. But if you wanted to attempt reasoning without the explicit thinking trace, go ahead and push that temperature back up to 1.0. Oh, and you can easily toggle thinking off entirely in your chat template arguments just by setting Enable Thinking to false.
Just a super quick troubleshooting note here. If you successfully dodged that CUDA 13.2 bug we talked about, but your model is still spitting out gibberish, well, your context length might just be set too low for that hybrid reasoning trace. Double-check that you have an adequate output length of at least 32,768 tokens. If that still fails, try setting your key value cache type to BF16. That usually does the trick.
All right, final stretch. Section 5, Setup and Real-World Performance.
So the most crucial point here is just how completely frictionless the Unsloth team has made this entire process. Installation literally takes between 20 seconds and a minute using a simple curl or pip command in your macOS terminal or Windows PowerShell. After that, you just launch it, open your local host at port 8888, and search for Qwen 3.6 MTP right in the Studio interface. Hit download, and Unsloth automatically sets up those ideal MTP and thinking parameters optimized perfectly for your exact hardware. Honestly, it's beautifully simple.
And look, while Unsloth Studio is fantastic, the broader ecosystem is incredibly flexible. You can absolutely run these exact same dynamic 4-bit quants directly through llama.cpp if you're a command line purist. If you're rocking an Apple Silicon Mac, they're MLX dynamic quants optimized specifically for you. And if you're looking to deploy this in production to back your own apps, just spin up Llama Server. It instantly gives you an OpenAI-compatible API endpoint that works natively with the OpenAI Python library or coding agents like Claude Code.
Okay, to wrap up the technical data, let's talk about the final benchmarks for multi-token prediction. The tangible speed gains really depend on the model architecture. For dense models, you're consistently seeing that massive 1.4x average speed up. For MOE or mixture of experts models, the speed up is slightly lower, hovering right around 1.15x to 1.2x. But across the board, no matter the architecture, MTP is universally pushing the boundaries of what local hardware can generate per second. We are genuinely at a point now where local, quantized AI models running on everyday consumer hardware are hitting generation speeds and reasoning capabilities that rival those expensive, gated cloud APIs from just a few months ago. It's a real game changer. So I leave you with this. With all of this incredible power now sitting freely right on your desktop, what groundbreaking tool are you going to build first?